Okay, is everyone here?
Everyone.
Please. Okay, we'll have quick recap by then so that it will be settled.
We can start with work today.
Sorry.
We can start with work.
Americans are left.
Only Americans are
We start work today, you said?
Wow. Chapter energy power.
Okay, in your school you?
I'm completed.
We are left with UCM part, right? We have to, yeah, we have to complete uniform circular motion and center of gravity. I think we did.
Centrifugal force.
Yeah, only some part.
We taught us how to do the numericals based on center of gravity.
Okay. Yes, we'll do quick recap of what we did in last class. Majorly, we are done with the force part. Only brief in-depth part of gravity was left. I think we just introduced what center of gravity is. Did we discuss more on? I'm very bad with the names, but please tell me your name so that. Okay, Pratik, settle down. And I am here, not that side. If you can, if your angle is fixed like this, it will be better. It keeps rotating. I don't know why. Yes. I know why it might happen. Torque effect over turning effect, but let's fix it. Okay. I don't know if I have discussed it this class, so I'm asking. Center of gravity part was done, and center of gravity, did we go in depth? Did I explain how center of mass and center of gravity are different or similar? Okay, and maybe this you would know what is the center of gravity. Sorry, okay, what? Okay, you can talk to them. Who all of you? Let's not. I only have 1 hour. Let's not waste most of the time in this part. Who all apart from you have not got those books? Is it only you? What is your name? Harshita has not got those volumes. What about others? Everybody is having apart from Harshita? Yes or no?
Yes.
Okay, Harshita, it is only you. Okay. I personally teach from textbook, but I do give numericals as a book from volumes. I do. There are quite good questions of past year, so it's important. So Harshita, after this class, remind me, this is our last class. Yes, a quick recap of the center of gravity. Center of mass. Center of mass and center of gravity will do that as well. Yes, I am here and speaking. Actually, we should do some rest. Please tell me what is center of gravity of a circular disc. I want the location of center of gravity of a circular disc. Can you tell me that? It's the center of?
It's the center point of the circle.
Okay, the center point of not the circle. Mine was a disc, so the center point of the disc. Good. Can you tell me if, okay, now a logical question because you wanted difference between center of gravity and center of whatever. So there is center of gravity part, the location of center of gravity of, they are given one as hollow core and the another one as the same dimensions. My diagrams are not accurate, but read my words. So they are of same dimensions. This one is solid, completely made up of iron. This one is hollow, again made up of iron, but it's just the outer sheet. Okay. I don't want the exact location. Just by pure logic, can you tell me if I'm telling you that it is on this axis somewhere, because that is my rotation point, which of the center of gravity point will be above and lower? If this is let's say this is A. I'll not give this is what is this? Solid core, right? Yeah, this is solid. This is hollow. If this is A, this is my center of gravity for the hollow cone. Okay. In solid core, my center of gravity will lie at A, above A, or below A.
At A.
These three.
When we diagonal intersecting, when we get a point, that is the center of gravity.
Where are diagonals coming here? This is core, this is core. I am giving you half answer that the center of gravity lies somewhere on this axis. Okay? I am giving you that answer. Okay? I just want you to answer whether this is A point. Everything is of same dimensions. There's only one difference. What is the difference? This is complete solid core. This is a hollow core. Please apply logic because we have done center of gravity, center of mass. You said that I did this in this class. A is here. I'm fixing the center of gravity point for this one as well. It is at A. Will in the solid cone, will it be at A, above A, or below A?
Below A.
Below A. Can one of you answer? Yes, the person at last. I think I asked you the question, right? So, wait. Harshita, can you answer why below? Did you answer below or you just came in below? Okay, why?
But because in hollow part the center of gravity is goes upwards and
So please continue. Why? I can make expression just to break you. Go ahead. In sentence,
just imagine the diagram in my head.
I want the logic behind this, please.
Ma'am, the center of gravity shift where the weight is more. So in the solid cone, below the metal is more, so it will shift below. The weight is more.
Okay, so what he's trying to say, in the pivot point also we knew that where mass is more. If I am adding more mass over here, if this was my center of gravity, I think I discussed this.
Yes.
My center of gravity will shift towards the point where my mass is more, right? In this case, everything was similar, but it is very much clear that above part and below part, here everything is solid. But compared to this part, more mass is on this side. So center of gravity has to shift downwards because it's completely hollow and there is more mass concentrated on the bottom region than the above region. Now, so at least I now know that it is somewhere below. And now comes your dimensions. Where is it located? It is in your textbook. If you remember, if it's done in your class. Yeah, but what is they have given you exactly height. Which part of
H by 4.
which one is H by 3? Which one is H by 4?
H by 3 and the solid core.
Yeah, because this is certainly less. So this is H by 4 and this is
H by
H by 3. Let's make it somewhat digestible. So 1, so this is 3 equal parts. This is H by 3. Okay, so where they trick you in this kind of questions, although you know everything, they might trick you in this. How will they trick you? They'll ask you, okay, what is the location of center of gravity for this hollow core? Okay, with respect to the tip of the pole. So can you answer me? Where is it?
Sitting at the same point.
No, with respect, in terms of this thing. Okay, I'll give you the option. How can you say this? Say, is it H by 3? Is it H? Is it 2H by 3? Or is it H by?
What does it mean with respect to the tip?
How far is it from the tip?
Oh,
I'm H by 3.
H by 3.
It's H by 6.
I'm 2H by 3. I'm H by 3.
It's H by 3.
I'm H by 3. H by 3. I'm 2H by 3.
Okay, I'll give you the answer. Okay.
wait.
So how many of you say H by 3, please? Only 2? Oh, 3. Okay. H तो कोई नहीं बोला. चलो good. 2H by 3. We have like 4, 5 of them. You change.
This I didn't change. I said H by 3.
H by 6. Nobody. Okay. So so there is something we have to do with this. In the previous case, when I said H by 3, I did not specify, but it was with respect to this part. Why? Because this is, what does H by 3 means? 1/3 of the total height.
Right from the base.
Right? 1 by 3 is 1/3 of the portion. This, if I'm talking about this point certainly is not, I have broken them into 3 equal parts. So this is 1/3. So 1/3h is with respect to base. And how far is it from here? I have already given you the diagram, 3 equal parts. So how far is it from the tip? 1, 2. So 2 out of those 3. So it is 2h/3. Okay, that's good. But in this case, can you tell me if correctly? Already you know this h/4 is which one now? Which is this with respect to base or tip?
Base.
Base, certainly 3.
Yes.
So what about from tip? Where is it? How far is it from the
3h/4.
3h/4. Okay. Yes, Swastika. Good. So we'll move from center of gravity. And this was your confusion.
I got confused from the.
No. Now you got this point. No, I'm asking you or somebody from your asked to redo center of gravity and
No,
center of
I just said
Recap.
quick recap of center of gravity.
Okay, so this shall do. Shall we move to our main topic?
Yes.
Okay. So today we will be doing uniform circular motion. It's basically the circular motion and what all forces play an active role in this kind of motion. Yes, centrifugal force, centrifugal. Okay, is it done in your school?
Yeah.
Okay, great. So I can have answers coming from you all. So let's say I have a fixed point and something is moving across it, and let's make this point as sun. Let's make this point as a moon. Oh, sorry. And why did I write it? Okay, so that's my earth. It is moving in circular direction across this center, which is sun. It doesn't look at the center. It happens over here. It is moving,
Yes.
and while it is moving, this sun is exerting some pull. We know which force is it pulling. Which force? Gravitational force. And gravitational force and the pull direction is towards, in this diagram, center circular motion. Okay, and such motion. Now this is just case of what? Sun and we can take some other examples like mostly there is they tie thread to a stone. Scarecrow, not scarecrow, but what in खेतों में वो जो स्केयर बर्ड्स को भी ऐसे घुमाकर से मूव करते रहते हैं, so that sound also, and वो पत्थर भी होता है उससे डरते हैं, और any which way we can do that. We can not rotate, sorry, we can move that stone in circular motion. Okay, so what is common? What I want you to tell me is two things. Obvious, what is common in these two? Okay, what is the other?
The middle
Point. Okay, in this is the first case,
Gravity.
what was gravity? In second case, what is? Oh, that's what I don't want you to say. It is here also. Okay, that's the concept that I want to come to. For any circular motion, okay, some kind of centrifugal force that is acting. What is acting in a circle? In this case, there is a center. Which force is actually provided? Force. Who said no? There is centripetal force. Are you getting my question? What I'm trying to say? Centripetal force was provided by gravity. All I'm asking is centripetal force is what did I say? Is
string.
exactly it's provided by the tension of the string. So there is something called tension, the tension force. It's the tension force which is provided to the center of centripetal force. Now let's move to, so centripetal force is quite easy. Now let's move to centrifugal force, where they try to confuse everybody again, although it's the centrifugal force. Like he said, it's the force which is moving in the outward direction, exactly opposite of the centripetal force. It is moving away from the center. What is the USP? Like, why always talk about centrifugal force? This force is always in uniform circular. It's any circular motion, because this is just a force called either pseudo force, SPSEUDO, pseudo silence, or an assumed force, which is not actually really there, but yeah, we also call it false force and imaginary force. Yes.
In that we're rotating the stone.
So
There is also centrifugal force present because the force is acting in the direction.
motions, like I said in previous case, in this case, in any surface, what difference make? Here providing centripetal force,
Gravity.
send again here in any circular motion. Now we are getting into, is there in reality there is no force like that. Who experiences that force?
The object.
The object which is moving. Yes. Say it's fine.
Not the person who is looking at the observer, the observer.
Okay. And so is actually the force. I am
Not
observer.
observer, sorry.
I am observer. I am seeing somebody playing what is a giant wheel. I am seeing somebody or giant wheel or whatever. Merry-go-round is obviously so what coming into this, please listen to this carefully. So I am the observer, I'm not in that wheel, I am in that thing, I am outside, I am observing the person, giant wheel or Ferris wheel, or merry-go-round or whatever. I am the observer right there, I am outside. Do I see that? Do I feel or do I imagine that, oh, that a person will fall down?
No, because we
No,
don't
I don't see attached to that piece. What in circulation can somebody just why does this happen every
One second.
If you know, please learn and how. So what's the So where were we? So when you observer, I see that person. The person was sitting. He will explain, oh, I will fall down. I might fall down. But the one who is on my front. So this force is not actually. ये इनको बता दीजिए कैसे या मुझे बता दीजिए क्या लगता है. So the one outside and the one who feels it is actually the imaginary feeling is experienced by the one who is experiencing that circle. Okay, so in reality there is nothing like that. That is why we call it as pseudo force. Or is this clear?
Yeah.
In this, okay, we come to direction. In inertia of motion is not there, only inertia of direction. And inertia, this thing we are doing here is you know what will happen. So let's say at some point this sun, the star, burns out and no longer is, is out and it's no longer there. So there wouldn't be any gravity anymore. So what happens is, if there is nothing like that, our Earth wouldn't continue to rotate, right? Neither would it start moving anywhere here. The moment our gravity switches off, it will start moving in the tangential part. Position. So this is the part where they every time ask that if this is the spring which is attached to a stone, at certain point the spring breaks. So where will it move? They might say in direction A, in direction B, in direction C, or direction D. So you should know that it should move tangentially, which is direction B. Okay. What all is remaining? Can oh, uniform is remaining. Rest I think we are done. We can take numericals and then we can finish it. So what is uniform circular motion? What uniform means in terms of English? Constant. Everybody over here has uniform height, though it is not. But if I say everyone over here has uniform height, it's same. So what in this thing? This object, if it starts moving, okay, if it starts moving, I can say that it is moving with uniform speed, but I cannot say it is moving with uniform velocity. Why? Because at every instant, direction is. I cannot say it is velocity, but yes, certainly if this starts moving, the Earth move up, sun, is it uniform motion? But we also know when it is elliptical path first and it's faster and the so as faster then it's slow, then faster and then it's slower. Okay, so that is not those textbooks give that as uniform motion, but pure logic and pure accuracy says
that slower or speed water has the fast. That rocket ship so fast. And when it was going at percent speed, and then it slowed. And that was the
but what are you? How are you trying? Okay, but they had too many rotations, and then it even went to some other place, and then had another kick from that place. So we have something. We have goes on increasing. It is moved to some other orbit. Then from there, I think for that only Earth was, and for the other planets which are very far, or even for the other locations. They even use the from here, the orbit is increased, then the second orbit reaches. What happened? From R?
Yes, ma'am.
It doesn't show anything. Swastika, Shaurya, can you not hear me?
Ma'am,
And
we
your
can
voice
hear.
is cracking at the end.
Yes, but
Okay.
Sorry,
I'll speak to hear me. Let me know. Okay, we'll get it fixed. Yes, there will be. I think we are done with this uniform circular motion. We've done that. So, what is uniform circular motion? We only talk in terms of speed whenever it comes to uniform circular motion. And if you are given an object has a uniform circular motion, okay, and I solve it over here, and we know that this whole path is how much? One revolution over here is how much?
365 days.
No, in terms of this path, distance is how much?
It's like
2 pi r. I was looking for that. If this circumference, it's 2 pi r. Okay. And if I say that some distance is covered in some time, and I get my speed in that sense, that how much of my distance is covered in how much time. Okay, this is not given in your book, it's not required. Then in case somewhere for uniform circular motion it is given, it should click to you that the path is what 2 pi, the circumference is 2 pi r. And most of the time the speed is not spoken in terms of meter per second. They will even use revolutions per second. The speed at which Earth is moving around the sun is 3 revolutions per second, 4 revolutions per second, or something like that. So speed, they can give it in terms of meter per second or revolutions per second. Please do not get confused. It is some other way. I'll be giving you questions. Please solve that numerical, and I think we can stop after those questions. Few complicated numerical that we are going to solve. And only now okay, I'll pick few from textbook which I think are important. If you have any doubts, you can text that textbook and give me the
sticky notes.
There are no numericals for this chapter.
What?
I know not there are.
There are numericals.
But
I mean, first letter 69.
okay, we can have this. I don't think it's solve, but please don't see the solution part. It's a good question that question 11, page number 9. Interesting question. Try to solve it on your own. Page 11. An interesting question. Instead of directly answer, try to understand it on your own. Take help of solution. I would not take help of solution. Question 7. Page 7. Sorry, page 9. Page 9. Question 11. Yes, but it is very interesting. Solve it and now I'm done. Here, suppose a pivot point. There is some object like this. It has a pivot point. It is fixed here. Let's say this is my object. This is my pivot point. This object, what will happen if it has one pivot point? It is able to move like this. Okay, it is able to move like this. What they do is they fix this point as well. Okay, I have not added this mass as of now. So please put your logic without using this mass. So what happened? It was free to rotate like this. Okay, if it had mass, certainly it would have gone down because of the weight of the ruler. Now that spring balance, what the spring does? What is spring balance? You know, right? We use it to measure what? Weight of the body, right? They fix this point to a spring balance, but they are not letting spring balance, fixed to this and even spring balance is rotating like this. No, they are fixed. Spring balance somewhere. Okay, so spring balance is fixed here. There is one pivot point which is fixed here, which is what is the first? It is fixed to pivot point because of the weight of the ruler. It has certainly has to go down. But now I fix one spring balance. It is attached to the edge point. What will spring back upwards? Let's say that spring is very it resists deformation very easily. It's not some any plastic spring. It's metallic spring. It's powerful. It pushes it backward, and in that case, it pulls upward. Now it is somewhere we don't know, but to make it balance, like not balance, to make it at equilibrium position, which is like straight, add another weight at 40. What will 40 try to do? It will again try to. What will 40 try to do? It will try to pull it down. So after applying all this thing, one is pulling upwards and one is pulling downwards or whatever, this combo, we get this at equilibrium, everything is balanced. Okay. What in first case, what they are asking you to do is get the reading of spring balance. Spring balance will give you the whatever by whatever force it is pulling, if by whatever force this is pulling downwards or whatever, it has to be some force value, because spring balance gives you weights value and weight is nothing but force. We'll get to see that. This is 40 kgf. This is what did they say? They have written very clearly that this is a uniform rod. It is a uniform rod. In cases when my what is this? My object is not. Let me complete. I have not placed my object at a point which is my center of gravity. What is the center of gravity of this point? Right. So there is some weight that is going downwards. That is weight of. But in this first case, they want to make it very easier for you. They say that the weight of this ruler is negligible. Weight of this ruler is negligible. So you can completely ignore this. Let the be there, but there's no you need to use the weight of the ruler. So we have to solve the first part now. What is this is pulling where downwards. Even the weight is this should, if it was there, it will pull downwards. Everything was pulling downwards. Only one thing was the spring balance was pulling it upwards, and because of the spring balance, this is equilibrium.
Yes.
Is that clear? Yes. Now, pivot point is here. Is the same side, right? Are we having something on this side? Can we do W1 R1 is equal to W2 R2 or W1 L1 is equal to W2 L2? No. What is the concept that we will use? If something is pushing it downwards, if some torque is
Anti-clockwise is equal to
yes, if the torque at this point and this point together pushes it, of course this pushes it equally upwards.
yes.
Yes. Right. So 40 kgf weight, moment of force due to 40 kgf.
40 into 40.
40 into how far is it from the pivot point? Okay, 40. In first case, we don't have to worry. We are kind of lucky. So this will result in clockwise. So this is clockwise moment of force. What is anti-clockwise moment of force? Who applies anti-clockwise moment of force? The spring balance. So anti-clockwise moment of force due to spring balance, how much it should be?
100 into the force applied.
Yes, that is my pivot point century. So that is 100. And what my force? We don't know. We need to find that. Since they have said this is an equilibrium, these both are equal. What is my F then? F is
equal to 40
into 40 by 100.
16 kg.
16 kg. Right?
Yes, ma'am.
In the second case, they give you what? They give you weight of
Mass
the rod.
20 kg.
They give you
20 kg mass.
WR is what?
20 kg.
20 kgf. Right? For the second case, can you give me then what is the spring balance reading? Because here, yes.
We just had 20 into 50 to 40 to 40.
Sorry, what?
We had 20 into 50 to 40 to 40.
Okay. Yes, yes, we are going to do that. So this part, it's fine. So AC, the anti-clockwise moment of force is only one, right?
Yes, ma'am.
There is here. Anti-clockwise moment of force is only one. It's provided by spring balance. But in the second case, when they say that weight of rod is not visible, but it is 20 kg, so weight of rod is applied at which point? 50. So there are two clockwise forces, this one and this one. So my total clockwise moment of force, just writing total now. Total clockwise moment of force is first due to this one,
Yes,
40 into 40 plus second one is what?
20.
20 into 50 because that is my. So now, sir, again, the case is it is at equilibrium. So now in this scenario is equal to this. So what is this? This is 1600. And how much is that? 1000. So that is 2600. Just start that. So F is 6. Is this clear?
Yes, ma'am.
This question was kind of interesting and important as well because unlike the other questions, there's only all of those forces is on. So there you can't do W1, L1 is equal to W2, L2 or whatever. Understand? And do it. Can I give you next question? Please give me the 6 points I have. Okay. Okay, this is very easy. So please question page 11 and it is asking you to draw a diagram as well. So please draw a diagram as well. What can you do of this? Okay, so page number 11 and question 7. A steering wheel of diameter 0.5 rotated anti-clockwise by applying two forces. You need to draw a diagram where you show the application of forces and then calculate the moment of forces. So please solve this question. And Harshita, today you can take a picture. Tomorrow if you want to make something. What I can don't say I'm not going to book or pencil or pen. If you can't give an excuse, don't cook up such bad excuses. Okay, please solve that. First rough diagram will do. They are just asking you to draw a diagram and represents where the forces are happening. It's what happened? What was book? What are you? Okay. The question says it talks about couple if I'm not wrong. So for that moment of force is what? Please remember it.
F into
Please, I have asked me what you have. Okay. Show me what you have. What's the question? I'm listening. Okay. Okay. See where. Please pay attention. Where you could have made error. The first question was that it is a steering wheel, so we'll make okay. And then they say that you have to show where the forces are acting, and of course they have that it is 0.5 of diameter. So let's say right.
Yes.
So 0.25 meter is my radius. You can write the diameter. That is also absolutely do this and write everything is for me. They have asked you to show the direction of the two forces. Since they said the motion is in direction anti-clockwise, so I can show my anti-clockwise like this. Right? Now I'm applying force. This is my steering wheel. I will apply force. I will apply force like this, right? I just force. What is my force direction?
Tangentially.
If you had drawn your force direction as like this, then what was the formula for F into perpendicular distance from the pivot point? Do you remember?
Yes,
So that is why the question was easy, but the direction, how do you draw was very one. This is at 2 is this. Your answer becomes very easy because this is my force, which is 5 Newton if I'm not wrong. So 5 Newton, I'll keep everything the same. And what is the pivot point's distance?
Diameter is
5
5 meter.
into
What
what is the pivot? And you multiply your and unit of course is what? This is this direction. Yes.
0.25.
Yes,
0.5.
Yes, sir.
Ma'am, what is the symbol which you have drawn?
The couple, sorry. The couple. But the direction is.
We take the first one.
Then you take this half. Then you take the so this thing. Let me take the other one. How much time? Okay, it's been too long that we have solved this question. Okay, take this one. Question 10.
Ma'am, what is the symbol which you have drawn?
Okay, please be quiet. What are you
Ma'am, what
saying?
is the symbol which you have drawn before is equal to
Torque.
torque?
This is for torque. Question Page number. Okay, we have from our volume now because it was previous year's question. So can I have one volume? Yes.
Numbers.
Do you not have any book? Both of you, what's her name? Ask for books. Can you give one textbook to them? What? You are having two textbooks? Give one. Okay, see the 10th question now. Let's solve it together. Okay. In this question, they have made it quite easier for you. They have said there is a rod and there is center of gravity and it is. You can copy it later. Please pay attention. And what is your name? Pay attention over here. So it is pivoted at this point, and they have made it very easier for you. They have made this point as 0. They have made this as 0. This goes up to what? If not on 50, and here also goes up to 50. And at this point at 40, how much weight is placed? 40 GF is placed at this 40 point. And of course that is, and they are asking you where will you weight, since to balance equilibrium. This is 40 GF. Yes. Of course, so we don't know where we keep it. That is 80 AGF.
So that would be L1.
So W1 L1 is equal to W2 L2. What is that?
Is equals to
80 into 2. And L2
equals to 20.
20 and 20 where?
Centimeter. The right
20 to the right of the center. Okay. Did we solve question 3 of volume page 5? It's last year's question.
Yes, ma'am, we did this
Not
now.
last year's.
Page 5.
Okay,
Yes, ma'am, it is done.
Okay, if it is done, then It's question 17.
But there are two questions.
No, there is only.
And 17. There is only 18 as so.
What's the and question number? What's the question number?
And 17.
Solve swastika us. 17 on page 51.
Your internal. Then I can explain.
This key.
Please.
Ma'am, your voice is cracking a lot.
Are you able to take? We will ask questions. The ones who go punishment would have some penalty. So let's see. We solve this 5 minutes and take that question. Please solve this question. Last 5 minutes we want for our question answer out. And this question should be done. I won't let anyone who has not solved go out of this class. Better solve everyone over here, especially both of you and you. And Sarvi, I know you're very good at not writing anything, but this question you have to solve. So good, right? This one in neat and writing everything. You have to write. There's no reason. We will discuss this for after that. Who said they are not doing that? Check for this part where you have gone, and after this we'll have questions, and I won't let anyone go at least this question neatly. You can't decipher what you have written, okay? So write it neatly. The question of this part was again easy. but it had some parts where I think few of you must have gone wrong, may have gone wrong.
Ma'am,
This is
can
my
50.
pivot point. What 50? This is a meter scale. There is 50 Newton of force and 5 Newton and 5 Newton. Who was that? 5 Newton downwards, 5 Newton upwards, and this is a meter scale. So this point is how much? 50 what? 50 centimeter. Okay. And what have they asked you to find?
The resultant
Magnitude of the resultant force.
The force. Have they asked you to find resultant force?
Yes,
ma'am.
Please read it again.
The magnitude of the resultant force.
Determine the magnitude of the resultant moment of these forces about the midpoint.
So it's not forces, it's moment of forces. Those are two different things. Please remember. What happened? What is wrong with you? Why are you smiling or laughing? I don't know what. Yes, of course. I am asking you. See, if you are having fun, it's fine because I don't want this class to be very boring, so that you sleep, doze off, and do not understand. But let's not make it that fun that you do not get anything and you just have fun. Let's strike a balance. Otherwise, we can have meeting with the director, you, your parents, me, the one who's causing the trouble. Let's not do that. I have been a decade ago, more than a decade ago, I was sitting there. I know physics classes can be boring if there's a monotony. But let's strike a balance. So this is 50 centimeter. I don't know who it was who said there's no unit given. So there was a meter scale given. So that's 50 centimeter there. Again, they are not asking you to find forces. They are asking you to find moment of forces. Those are two different things because moment of force unit is Newton meter. It's a new concept. Force is just Newton. It is force. Okay. Here they are asking you moment of force, not just because of this, because this part will push it upwards, this part will push it downwards. In all, they will add for the same anti-clockwise moment of force. So we have two, and if you see this together, this is nothing but what? A couple. And what was the formula for moment of couple? It was nothing but one force, 5, and distance between those two.
100.
No, distance between those two forces, because this and this added, so we took 5 common, and this is a shortcut. You can go for the log cut as well. But then distance between both of them, if you write in terms of meter, because we are talking in terms of SI unit, we will simply take 1 meter, and the answer is 5 Newton meter. Okay, if you want to take a longer route, you can write it as 100 centimeter, but then make sure you do not give your answer in meters. It should be in terms of Newton centimeter, which your teacher might accept, but then it should either, everything should be converted either in that centimeter or Newton meter. Yes, 500. So if you are putting in terms of Newton centimeter, is that clear?
Yes, ma'am.
Yes, ma'am.
Please do not go wrong anywhere in this cases. If you are putting your answer in terms of Newton meter, put your dimensions, take your dimensions also in the same unit. And we can have a quick question and answer round, and we can leave. The one who answers can leave, okay? And the one who cannot answer can leave that, listen to others, and the questions will come back to you. We'll start with yes, you. Formula for momentum, please. Only momentum. No, which class is this? Momentum. Yes, I am saying momentum. It is your class. Yes. Only momentum, not momentum of some force. What was the formula for force? I am and the very first class I told you, the representation given in your book is dp by dt.
Yes, ma'am.
The P represents momentum. What was that momentum? I'm asking for that. Mass into answer this before. Okay, I take this. So that momentum is different. And when you say moment, and that was momentum, by the way. I also thought why you got confused. That was momentum. This is moment of force. see the difference. Okay. Yes. SI unit of momentum. What is formula for momentum? Okay, what is formula for momentum? Yes, you the. Okay, so you know the formula for momentum. So what is SI unit for momentum? You want
Ma'am,
can you? Yes, Swastika, if you can answer, please.
kg meter per second, right?
Sorry, what?
It's mass into velocity, so it should be kilogram meter per second.
Very good, Swastika. If you want to say, you can say, or you can leave the session as well, because you gave an answer. Thank you. So it's kg meter per second in the formula. Even you can leave. You give mass into velocity, right? The next one over here. Please tell me what is. I am giving it very easy. So SI unit first, please. You. No, I'm asking you. Yes, you. What? Force, yes. What? And what is relation between Newton and Dye?
Can I tell?
Why? Shaurya, please give me relation between Newton and Dye.
A 10⁵ dyne is 1 Newton.
Okay, please leave. Can you give me relation between Newton meter and Dye centimeter?
10⁷.
Okay, please leave. You, Salim. No, not you. Yes, the one whom I asked. Okay, you can wait. Yes. Difference between couple and torque, please. I gave you easier one. You can read. Pratik, you can answer if she is not able to answer. No, if she is not able to. They told her also. Pratik, please.
Torque is a turning effect. Its SI unit is Newton into meter, and couple is equal to anti-clockwise.
Can I
And parallel and equal forces does not acting in the same line.
Initially you're wrong, but then you understood. Go. Yes, please tell me unit of SI unit of couple, please. SI unit of couple, please.
Newton.
Stick to one. Give me if it is wrong. Give you here. Newton meter. Yeah, it's the same, right? So it's turning it. Go. Yes, will come to you. What else is it? Yeah, I don't keep it. Center of gravity of a hollow core.
Ma'am, HY3.
From where?
Ma'am, from
Ma'am, to
the best.
What about the solid core?
I'm into